Hey guys, just got a liquid nitrogen dewar, sort of as an early Christmas present. Figured let's have some fun with liquid nitrogen. I've seen LEDs like this put in liquid nitrogen, they should change color. Never seen a big power one like this put in, so let's give that a try. My friend who gave me all that stuff for teardown recently also gave me this thermos. It's pretty deep, so it'll be a little bit hard to see what's going on, and it's not transparent, it's silvered, but should be a good vessel for doing this in. I picked up this dewar on eBay. It's a Brymill MVE SC 2020. I picked this one because it has a pretty long holding time, 220 days. That means it'll take about 7 months for the full fill to evaporate down to nothing. Which is pretty important because this is not something I'd be using all the time, so it's good to not have to fill it too often because of evaporation. Okay, there we go. That should be enough. That's boiling away nicely as it cools the dewar down, or cools the flask down. First time I've tried this out at this low temperature. I tried this a little bit with some just inverted dusting gas, and it seemed to indicate this thing had vacuum. Yep, this does. I might need a little bit more than that actually. That ought to be enough. Pardon the pun, but liquid nitrogen is just so cool. If we cool this down, get this out of the way, you can see it like jetting out of all the little holes in this foam RF gasket. Oh, that's so cool. Anyway, onto the LEDs. Let's see, I've got set up a really old red. This is from the 70s, I think. It found an old collection of electronic components. So this is running at 20 milliamps. It's a pretty, the scene is not lit particularly brightly, so yeah, this is not a very efficient LED. We expect the wavelength to go lower, so more towards orange as we put this in. It doesn't actually seem to be changing that much. It's getting a lot brighter, I would say. But yeah, it's not really changing color, huh? Maybe it's only those orange LEDs that really change color. Nah, I'd say it's about the same brightness as before. So this is a much more modern LED. This was in this pack. What was this from? Yeah, this was just from one of the local electronic suppliers. 590 nanometers. It's not quite. Sort of, mostly orange. Has sort of a yellow, yellowish plastic on it. Let's see what we get here. Now that is getting I would say that's way brighter. But again, no color change. Yeah, I was expecting color to change. I guess you need a specific type of LED for this to happen. Let's see if as this warms up, if the brightness changes at all. Not really. The color changes very slightly. I guess it went from, this is sort of yeah, it went more yellowish, I would say. Let's try that again. Definitely gets way brighter and turns much more, yeah, it turns yellowish. You just can't really see the color change quite as much. It's not as extreme as some of the other ones I've seen where it turns from yellow to sort of almost mostly green. And here's the one you've probably all been waiting for, 100 watt LED. We've got this running at about 10 milliamps forward current, and we've got a meter measuring the forward voltage drop. So let me turn down the iris so we can actually see the color better. Yeah, the reflection off of the sides should be a good indication. So make sure you can see the forward voltage there. So it's definitely going up. I suspect the phosphors may stop working at low temperatures, so this may turn bluer. 20, oh yeah, voltage is going way up. I've got this in constant current right now. Wow. 40 volts. Huh. That's nearly, yeah, from 20 volts up to 40 volts. Wow. Although the color, I don't believe, has changed very much. Oops, we cracked something. I think we probably cracked the ceramic plate behind the LEDs because we lost one entire row there. Come on, let's see if we can see that. Yeah. So these do not take well to being at this low temperature. The other ones are starting to go dimmer. Let's run a bit more current through this. That is 100 milliamps now at 44 volts, almost 45 volts. Yeah. Yeah, that did not handle the low temperature very well. Oh, let's crank it up. If I power supply, we'll even go that high now. There's 200 milliamps. And there's 400, boiling pretty nicely. We are at 49 volts now. Yeah, we've only pretty much got the two end rows of the lamp actually working anymore. Let me turn the iris way down. Let's turn the current up now. Oh, it's still going to clip, isn't it? Half an amp, 50 volts. Let's see if I can, just in case this splatters up, I probably shouldn't have my hand above it. There we go. Power supply's cranked all the way up. We have up to 60 volts now. There's 1 amp. 51 volts at an amp. 1.5 amps, 52 volts. 2 amps, 52 volts. It's actually going down now. 50, yep, as it's heating up, the LED voltage is dropping. Oh yeah, then the top column has gone completely out now. Let's try it up. Can the iris go any lower? Oh yeah, it can. Let's try it all the way up. 3 amps. Whoa. 54 volts, yep. Okay, let's pull that out and we'll let that warm up. Well, look at all that smoke or steam, or actually water vapor. Yep, 4 rows are dead, it looks like. Although those 4 rows appear to be operating. Oh, there's one just came back on. Some sort of thermal effect there. Voltage is getting more normal. Oh, no, a different row has come back on. It'll be like a disco light as the temperature changes. How warm is this now? It's still very cold. That should heat it up a little bit. Have we melted the frost yet? No, now it's not quite as bad. It's about 30 watts there. There we go. Oh, cool. Yeah, you can see the temperature gradient moving out. That's about enough of that. Yep, just around freezing. Yeah, so we cracked the phosphor pretty badly. The phosphorus is sort of a gel consistency material. That's just completely cracked from the thermal shock. Yeah, let's see. Let me look closer. Don't know if we'll be able to see where the actual failure occurred. You definitely see something under the phosphor here that is cracked. Let me get the camera in closer. Yeah, you can definitely see something around here. Looks like the ceramic coating or whatever the insulator is used in the back of this has cracked. The plastic casing seems to be okay. Don't see any problems there, as is the metal. But yeah, I guess that ceramic doesn't handle the temperature shock. Temperature shock very well. Let's try and turn this up a little bit. Down there, yeah. Yep, so those 4 rows are completely gone. This was one of those super cheap Chinese LEDs, so the intensity, some LEDs have more leakage current than others, although this one is a relatively good example for one of the cheap Chinese LEDs. A lot of them are much worse than this one. Some chips won't come on until much higher currents, but I guess I happened to luck out and get a good batch on this one. Actually, come to think of it, it may not be the substrate cracking that caused the LEDs to fail. Now, because I noticed all these cracks, they go, the bond wires go in this direction. So it's probably actually the cracks here. Like this crack has gone right across those. That probably has cut the bond wires in that area and caused it to stop working. Well, that was fun. If there's anything else you want to see run in liquid nitrogen, or anything else you want to see done with liquid nitrogen, please let me know. Anyway, got to get rid of the little last bit left in this, so here we go. Ooh. All the steam or vapor going everywhere. Anyway, thanks for watching. I just noticed we can make sort of cups of cold. Pour, because it's just air. It's really cold in here, and if we turn it, we can just pour that out.